Hey everyone, and welcome to another deep dive. Today we're going to be looking at something pretty fascinating in the world of AI. Now, we all know that AI needs data, tons and tons of it. But what's really interesting is how those massive models are actually trained. And it might not be what you think.
Yeah, that's right. I mean, you always hear about these huge data sets, right? And you naturally think, okay, that data has to live somewhere complex and fast, like a really high-end file system. But there's a twist.
A twist. But now you've
Yeah.
got me hooked. So if it's not all about these fancy file systems, what's the secret ingredient then? What are these AI masterminds using?
The answer might surprise you. It's actually something that's often seen as much simpler, almost old school. We're talking about object storage.
Hold on, object storage. Now, that's not what I was expecting. I always thought of that as more for archiving data, like long-term storage, not something that could handle the intense demands of training an AI model. This is definitely a curveball, so spill the beans. Why are people turning to this seemingly simple tech for AI?
Well, it might seem counterintuitive, but object storage actually fits really well with how AI training works. To get the full picture, though, we need to kind of break it down into the four main stages of how these large language models are made.
Okay, yeah, that makes sense. Let's break it down then. Starting with phase one, what's the first step in this whole AI training process?
First up, you've got data ingestion. Picture this. You have these massive web crawlers. They're like digital vacuum cleaners, right?
Yeah.
Scouring the internet, sucking up everything they can find, web pages, articles, code, you name it. And we're not talking just a few gigabytes here. This is hundreds of petabytes of raw data. Just imagine it.
Hundreds of petabytes. Whoa, I can't even wrap my head around that much data. I'm picturing like rooms and rooms filled with hard drives.
You're not wrong. It's a crazy amount of data. But this is where object storage really starts to shine. See, it's incredibly efficient at handling this kind of massive influx of data that's mostly write once. Think of it like a giant, well-organized digital warehouse. You just keep piling things in, and it effortlessly keeps track of everything.
So it's not just storing the data. It's like this massive data organizer. Okay,
Okay.
that makes sense. But once we have all this data, what happens next? How do we make it usable for an AI?
That leads us to phase two, data preparation. Now, this is where we get down to business. All that raw data we just ingested. Think of it like a giant, messy jigsaw puzzle. We got to clean it, sort it, and make sense of it. This means filtering out anything irrelevant, removing duplicates, and then a really important step, tokenizing the data.
Tokenization. That sounds pretty technical. Can you break that down for us? What exactly does that involve?
Imagine taking a sentence like, object storage is awesome, and chopping it up into individual words. Object storage is awesome. Those are tokens. It's like translating human language into something an AI can understand.
So it's like transforming a giant messy library into a well-organized digital catalog where every word is neatly indexed and searchable.
Precisely. And you guessed it, object storage is perfect for this phase too. Every step in this data preparation involves working with data in chunks, which plays right into object storage's strength. It can handle these large operations with no problem, making the whole process super smooth.
So object storage is like the ultimate data librarian.
Mhm.
Amazing. Okay, so we've gathered the data, we've cleaned it all up. Now comes the really exciting part, right? The actual training.
You got it. Phase three, model training. This is where those powerful GPUs come in. You know the heavy lifters of the AI world? Picture a massive server farm just humming with activity as these GPUs crunch through all that prepared data, learning and refining the model. It's pretty incredible.
No, this is where I'd imagine those super fast parallel file systems come in, right? All that data being read and written constantly, it seems like it would need a ton of speed.
That's what most people think, but it's not completely accurate. That speed is definitely important. AI training works a bit differently than you might expect.
Oh, really? So it's not just a race to process data as fast as possible. Now I'm really intrigued. Tell me more.
The key here is that training doesn't actually involve accessing tons of tiny files constantly. The data is actually bundled into larger objects, which is something object storage excels at.
So even in the middle of this intense training process, object storage is still holding its own. This is fascinating. What about the amount of data, though? Just how much are we talking here?
Well, believe it or not, even a huge AI model might only need to read a few gigabytes of data per GPU over a 2-month training period.
Wait, seriously?
Yeah.
That's way less than I would have thought. So all this talk about needing these crazy expensive file systems for AI training, it's not always the whole picture.
It's about picking the right tool for the task, and in this case, object storage is often the smarter and more cost-effective choice. Plus, there's another crucial part of training we haven't even touched on yet, checkpoints.
Checkpoints. Is that like hitting save in a video game so you don't lose your progress?
Exactly. During training, we need to save the model's progress regularly. Now, this is one area where speed is super important, wouldn't you say?
Oh, absolutely. Can you imagine losing hours or even days of training progress because of a slow save? That would be a nightmare for any AI developer.
And this is where things get really interesting. Even a model with 1 trillion parameters, which is mind-bogglingly complex, can be super efficient with a relatively normal file system.
Okay, now I'm hooked. How is it even possible?
The secret is using object storage to our advantage. We prioritize writing large blocks of data, which object storage handles really well, and we optimize the checkpoint process to work seamlessly with that. It's all about working smarter, not harder.
Object storage is like the AI whisperer. Amazing.
Yeah.
But what happens once the model is fully trained? Where does object storage fit in then?
That brings us to phase 4, deployment and inferencing. This is where the AI gets to show off all it's learned, answering questions, generating text, basically putting all that knowledge to work.
So it's like graduation day for the AI. But where does object storage come in during this final phase?
Object storage's simplicity really shines here. We need to be able to load and swap different AI models for different tasks, right? Like searching through documents or having a conversation. Object storage makes managing all of that super easy.
It sounds like object storage really is the ultimate AI sidekick. It's versatile and adapts to all the different stages of the process. This has been eye-opening. I never realized how important object storage was in the world of AI.
You've got it. And when you think about the sheer amount of data and all the steps involved in training these AI models, it's clear that object storage's scalability and cost effectiveness really make it a game changer. It's the perfect tool for the job.
I'm honestly blown away. This is so much more than just storing data. It's like the foundation for this whole AI pipeline, enabling everything to run smoothly and efficiently.
Couldn't have said it better myself. And as AI continues to evolve, object storage is going to become even more vital in shaping this exciting field. It's an exciting time to be watching all of this unfold.
I can't wait to see what the future holds. But before we get ahead of ourselves, I want to remind our listeners that if you're interested in exploring the world of AI and maybe even training your own large language model, you should definitely check out Stonefly's AI servers.
They've got some seriously impressive solutions that are custom built for AI workloads. It's like having your own personal AI training ground.
To learn more and schedule a demo, you can reach out to them at sales@stonefly.com. They'd be happy to help you unlock the power of AI for your business.
Now let's dive even deeper into how object storage actually makes all this magic happen in AI training. We'll explore the specifics of each phase and look at why those subtle differences make such a huge impact on performance.
Sounds like we're about to get even more technical.
Yeah.
I'm ready for it. Let's keep this deep dive going.
So let's go back to that first phase, data ingestion, for a minute. We talked about those web crawlers pulling in massive amounts of data. Well, it's not just the volume that makes object storage such a good fit. It's also the type of data we're dealing with.
Okay, I'm curious. What do you mean by the type of data? Is it different from other kinds of data?
Think of it this way. Most of the data we're collecting for AI training, it doesn't really change once it's been written. Like if you download a web page today, the content is basically frozen in time.
Right. It's like a digital snapshot.
Yeah.
So are you saying object storage is good at managing this kind of static write-once data?
Exactly. It's designed for this kind of workload, capturing huge amounts of data and storing it efficiently so we can easily access it later.
That makes sense. But let's just play devil's advocate for a second. What would be the traditional approach if we weren't using object storage?
Traditionally, you might think of using parallel file systems, especially those designed for high-performance computing.
Yep.
They're built for speed and handling lots of requests at the same time.
So why wouldn't they be the best choice for this data ingestion phase? What's the downside?
The thing is with data ingestion, we're not constantly reading and writing small bits of data from millions of files. Instead, we're taking in these large chunks of data, whole web pages, images, videos, and organizing them into containers.
So it's like using the right tool for the job.
Hmm.
Parallel file systems would be overkill in this case.
Exactly. Object storage is much more efficient for handling data on this scale, and it does it without breaking a sweat.
All right, so object storage wins round one. What about phase two, then, data preparation? How does it handle all that cleaning and tokenization we talked about?
This is where object storage's ability to handle large sequential reads and writes really shines. Remember, we're working with big chunks of data here, transforming that messy raw data into a well-structured library for the AI.
Right, we're basically teaching the AI to read.
Exactly. Each step in this process, filtering, deduplicating, tokenizing it, all involves reading a large chunk of data, processing it, and then writing the results back. Object storage is made for this kind of workflow.
So it's not just about where we store the data, it's also about how we process it. It's like a perfectly choreographed dance between storage and processing.
I like that analogy. Now let's move on to the heart of it all, phase 3. Model training. This is where things get really interesting because it challenges some common assumptions about AI and storage.
Okay, I'm all ears. Everyone always talks about AI training needing insane amounts of processing power and super fast storage. So how does object storage keep up?
Well, you might be surprised to hear that the demands on the storage during training aren't as intense as people think. Remember that number we mentioned earlier? Even a massive AI model might only read a few gigabytes of data per GPU over a couple of months of training.
Yeah, that was pretty mind-blowing.
And here's another key point. The input data doesn't actually need to be shared between all the GPUs during training. Each GPU can work on its own portion of the data independently.
So it's like a team of scientists, each working on their own part of a project without having to constantly compare notes.
Perfect analogy. And this lets us use a really neat trick called node local NVM.
Node local what now? Sounds a bit like something out of Star Trek.
It's not as complicated as it sounds. Basically, it means storing the data each GPU needs on its own fast local storage. It's like giving each scientist their own personal lab with all the equipment they need right there.
So we're basically getting rid of the need for a super fast shared file system by keeping the data close to where it's being processed. That's really clever.
Exactly. And this is where object storage comes back into play. It acts as the central hub for all the data, and we use it to move those larger chunks of data to each GPU's local storage before training even starts.
So object storage is like the project manager making sure all the scientists have everything they need before they begin their experiments.
You got it. Now we can't forget about those checkpoints during training. Saving the model's progress regularly is crucial, and we have to do it quickly so we don't lose any precious training time.
Right, because time is money, especially when you're dealing with these huge AI models.
And that's where object storage's strength in handling large sequential writes is a lifesaver. The checkpoint data, even for a complex AI model, isn't actually that gigantic. Plus, we only need to save one copy of the model's weights because all the GPUs are synced up during training.
So we're not wasting time and space saving multiple copies of the same data. Makes sense.
And because we're saving one big chunk of data at a time, object storage can handle it super fast and efficiently.
It's amazing how object storage is like the unsung hero behind all of this, quietly making everything run so smoothly. It's like the secret ingredient to successful AI training.
It just goes to show that using the right technology for the job can make a world of difference. But we still have one more phase to cover, deployment and inferencing. That's where the AI finally gets to show off what it can do.
All right, let's dive into that. How does object storage factor into this final stage?
Well, during deployment, we need to load the trained AI model onto the servers that will be handling all the requests coming in. And guess what? Object storage's simplicity and scalability are a huge help here, too.
I bet I can guess. Object storage to the rescue again.
You know it. Think of object storage as this huge library of AI models, each one ready to be used whenever we need it. And because it's so scalable, we can handle tons of requests at the same time without any issues.
So object storage is like that amazing librarian who can find any book you need in an instant. Except in this case, the books are powerful AI models.
Exactly. That kind of flexibility is super important in AI because we're always developing and deploying new and better models all the time.
I am definitely sensing a theme here. Object storage is all about efficiency, scalability, and adaptability. All those qualities are essential in the world of AI.
You hit the nail on the head. It's a great example of how sometimes the simplest solutions can be the most effective.
This has been an incredible journey. I feel like I've learned so much about object storage and its role in AI. It's so much more than just a place to store data. It's the engine that drives the entire AI process.
I'm glad you're finding it so interesting. The important thing to remember is that when it comes to AI infrastructure, we need to be open to new ideas and explore all the possibilities. Don't be afraid to challenge those old assumptions.
And object storage is definitely a technology worth exploring, especially if you're working with those massive data sets and complex workflows that are becoming the norm in AI these days.
Absolutely. Who knows what other amazing advancements are just around the corner? The future of AI is full of potential, and it's going to be a wild ride seeing it all unfold.
I can't wait to see what's next. But before we get too carried away, I just want to remind our listeners that if you're interested in getting your hands dirty with AI and maybe training your own large language model, you should definitely take a look at Stonefly's AI servers.
They offer some really powerful solutions that are built specifically for AI workloads. It's like having your own personal AI lab at your fingertips.
To learn more and schedule a demo, head over to sales@stonefly.com. They'll be happy to help you get started on your AI journey.
Now let's switch gears for a moment and talk about some of the things to watch out for when using object storage for AI. Like any technology, it has its limitations.
Okay, that makes sense. What are some of the potential challenges we should be aware of when using object storage for AI? So we've talked a lot about the good stuff, but every technology has its quirks, right? What about object storage? What are some of the things to watch out for when we're using it for AI?
Yeah, for sure. One thing to keep in mind is latency. Object storage is awesome for those big chunks of data, but when you need to grab lots of little files, it can be a tad slower than those traditional file systems.
So it's kind of like ordering a huge pizza for a party versus just grabbing a slice for a quick snack. The pizza delivery might be faster overall, but getting that single slice could take longer.
Perfect analogy. And that can be a factor in some AI tasks, especially those that need to access lots of small bits of data quickly.
So it's important to really think about what your AI needs and make sure those small file accesses won't slow things down too much.
Right. Another thing to consider is the whole ecosystem around object storage. It's developing fast, but there might be some specific AI tools and libraries that work better with traditional file systems.
It's like trying to use a record player with Bluetooth headphones. You can probably make it work, but it's not going to be as smooth as using components that were designed to work together.
Exactly. But the good news is the AI world is catching on to object storage fast. New tools designed specifically for this environment are popping up all the time.
So it seems like object storage is becoming the go-to for AI.
Yeah, definitely moving in that direction. And for a lot of AI projects today, it's already the best choice by far.
This has been an awesome journey. I feel like we've gone from AI novices to almost experts in just one episode. I never would have guessed that object storage was such a powerhouse for AI.
I'm glad you found it so interesting. The key takeaway is that we need to think outside the box when it comes to AI infrastructure. Explore all the options out there, and don't be afraid to challenge those old assumptions.
And object storage is definitely one to consider, especially with the huge data sets and complex AI workflows we're seeing these days.
For sure. And who knows what other amazing advancements are just around the corner. The future of AI is wide open, and it's going to be an exciting ride watching it all unfold.
I can't wait to see what the future holds.
Yeah.
But before we wrap things up, I just want to remind everyone that if you're ready to jump into the world of AI and start training your own large language models, you could definitely check out Stonefly's AI servers.
They've got some amazing solutions that are specifically designed for AI workloads. It's like having your own personal AI training ground.
To learn more and set up a demo, you can head over to sales@stonefly.com. They'll be happy to help you on your AI journey.
And with that, a huge thank you to everyone for joining us on this deep dive into the exciting world of AI and object storage. Keep those minds curious, keep exploring, and keep pushing the boundaries of what's possible in tech. Until next time.